Welcome back to Science and Slumber, the quiet corner of the universe where we unravel its greatest mysteries, one slow breath at a time. Tonight, we're going on a slow, soothing journey to a place of impossible beauty and quiet creation. We are going to ask a simple question, perhaps the most ancient one of all. How stars are born, how do they live, and how do they die? It sounds like a simple question, one you might have asked as a child looking up at the velvet darkness. But the deeper you fall into it, the more you realize it's the same question as asking where the universe's light comes from, where the elements that make our world come from, and even where we come from. As always, I hope this story helps you drift off into a deep and peaceful sleep. Or, if you choose to listen, I hope it keeps you pleasantly curious, floating in a state of gentle wonder. If you feel you have a moment before you drift away, you can tap the like button and maybe subscribe. It quietly helps this sleepy little channel grow, finding others who are looking for a bit of peace and perspective. Wherever you are, it's time to settle in. Get comfortable. There is nothing you need to do and nothing you need to remember. Just let the words wash over you, like the ancient, gentle light from a distant star. Ready? Here we go. To begin our story, we must first start not with a star, but with the space where a star will one day be born. We often think of space as a perfect emptiness, a black and sterile vacuum, a complete and total nothingness between the points of light. We imagine it as a vast empty room, and the stars and galaxies are the sparse furniture scattered within it. But this is one of the most beautiful misconceptions we have. The truth is far more gentle and far more profound. Imagine yourself floating in the deepest part of the cosmos, far from any star. The silence here is absolute, a quiet so deep you can feel it in your bones. The cold is not a biting, aggressive cold, but a settled, ancient stillness that has existed for billions of years. And it is not empty. You are not in a void. You are adrift in a vast cosmic ocean. It is the calmest ocean imaginable, so thin and so spread out that it feels like nothing at all. But it is there, a fine invisible mist of hydrogen atoms, the oldest and simplest things in the universe, hangs in the darkness. For every few feet of space, there is only a single atom, a lonely traveler in the night. Mixed with this ghostly fog are tiny microscopic grains of dust, like fine dark soot from a long-extinguished fire. This is the true nature of interstellar space. It is not an absence, but a presence, one so subtle it requires a cosmic patience to notice. If you were to cup your hands here, you would hold almost nothing, and yet the potential for everything is resting in your palms. This ocean of gas and dust is the raw material of creation, the uncarved stone from which all future suns and worlds will be sculpted. It is a place of profound and patient waiting. Each atom of hydrogen is a single simple note, and the dust is a fine quiet percussion, and together they are waiting for a composer to arrange them into a symphony of light. This cosmic sea is unimaginably vast, stretching for light years in every direction, and it is almost perfectly still, holding the memory of the Big Bang in its cold, dark waters. What this really means is that the universe is not a collection of objects separated by emptiness. It is a single, connected substance, a fabric that is simply thicker and denser in some places than in others. The great nothing we imagine between the stars is actually the everything that is yet to be. It is a quiet promise. Every star you have ever seen, every planet, and even the atoms that make up your own body, all began their story right here, as scattered, lonely particles drifting in this deep, dark and silent ocean. The space between the stars is not the end of the story. It is the cradle where every story begins. Yet this perfect stillness is not an end. It is a beginning. For even here, in the most silent and forgotten corners of the cosmos, a slow and patient influence is always at work. An invisible current flows through this ocean, a persistent whisper that, given enough time, begins to gather the stillness into a gentle cosmic tide. That gentle cosmic tide has a name we all know, but the name itself can feel misleading, heavy with the weight of textbooks and equations. We call it gravity, but for our journey tonight, let's set aside the image of a force that yanks and pulls, the sudden drop of a fallen apple. On the grand cosmic scale, gravity is something far more patient, far more subtle. It is the universe's quietest and most persistent whisper. Imagine yourself back in that still, dark ocean of space, surrounded by the thin mist of hydrogen atoms. Gravity is not a command shouted across the void. It is a suggestion, murmured from everywhere at once. To each and every particle, it whispers the same simple idea. Asterisk, come together. Asterisk. This whisper is so faint that for a single atom, it is barely perceptible. If you were one of those atoms, you would not feel a pull. Instead, you might feel a slow, dawning sense that one direction in the infinite blackness is infinitesimally more appealing than any other. It's like standing in a perfectly flat field, and after 1,000 years, realizing that the ground beneath your feet has a gentle, almost imperceptible slope. There is no push, no rush to move, but given enough time, you would find yourself slowly, inevitably, drifting in that direction. This is the true nature of cosmic gravity. It is a property of the universe itself, a slow, patient curvature in the fabric of space-time, a valley so wide and so shallow that it takes 1,000,000 years for anything to even begin to roll downhill. It is a beautiful and humbling thought to imagine the moment this idea first settled in a human mind, not as a complex formula, but as a moment of pure connection. To look at an apple falling from a tree, and to see in its simple earthbound journey the same invisible hand that holds the moon in its gentle orbit. It is the realization that the grandest and most epic movements of the cosmos are governed by the same quiet principle that we feel every moment of our lives. The universe, in that moment, becomes a more intimate and understandable place. The laws that shape the galaxies are the same laws that shape our world. What this really means is that the universe has an inherent memory of togetherness. Before the Big Bang, everything was one, and gravity is the universe's own quiet, relentless longing to return to that state of unity. It is the patient sculptor of the cosmos, and its only tool is time. Over millions and millions of years, its faint whisper begins to have an effect. In the vast, evenly spread mist of hydrogen, some regions, just by pure chance, are a tiny fraction denser than others. Perhaps a few extra atoms happen to be gathered in 1 cubic light-year. The whisper of gravity is slightly stronger there, and so, more atoms are gently coaxed in that direction. The slope of the valley becomes ever so slightly steeper. This is not a dramatic or violent process. It is as slow and as peaceful as watching frost form on a window pane. The scattered vapor doesn't rush to a single point. It gradually organizes itself into beautiful, intricate patterns. In the same way, the smooth, featureless ocean of primordial gas begins to curdle. Great ghostly filaments of matter begin to take shape, like vast cosmic spiderwebs stretching across the darkness. The emptiness is becoming organized. The stillness is beginning to stir. The patient gatherer is at work, collecting the raw materials for the masterpiece it is about to build. But this patient sculptor works only with the universe's oldest and simplest clay. That simple, ancient clay from which gravity sculpts the stars is made of the universe's first and most fundamental ingredients. To understand the birth of a star, we must first appreciate the beautiful simplicity of what it is made from. In the very first moments after the Big Bang, the universe was an incredibly hot, dense, and uniform state of pure energy. As it expanded and cooled, that energy condensed into matter, forming the first, simplest, and most abundant things that would ever exist: hydrogen and helium. Imagine hydrogen not as a gas in a balloon, but as the universe's first thought. It is the purest possible atom, a single proton at its heart, and a single lonely electron orbiting it like a tiny, faithful moon. That's all. It is the elemental blueprint, the cosmic number one. More than 90% of all the atoms in the entire universe are hydrogen atoms. They are the quiet, unassuming foundation for everything else. Helium is the universe's second thought, a slightly more complex arrangement, forged in the fiery nursery of the first few minutes of existence. Together, these two elements are the universe's inheritance, the only materials it had to work with for hundreds of millions of years. Let's think of the universe as a grand, dark canvas, waiting for its first artist. In this quiet early time, the artist had only 2 colors on the palette. Hydrogen was a luminous, foundational white, and helium was a soft, complementary gray. With just these 2 simple shades, the first cosmic paintings were made. The great swirling mists gathered by gravity were not yet vibrant with the fiery oranges of iron or the deep blues of oxygen. They were vast, monochrome masterpieces, painted in shades of primordial simplicity. Every structure, every filament, every slowly condensing cloud was a subtle blend of just these 2 ancient ingredients. There is a profound quietness in this idea that the universe did not begin with complexity, but with the most humble and elemental of starting points. What this really means is that everything that seems complex and vibrant in the cosmos today is simply a creative rearrangement of these first two simple atoms. Every other element on the periodic table, the carbon that forms the basis of life, the silicon in the rocks beneath your feet, the nitrogen in the air you are breathing now, none of it existed yet. The universe was a simpler, purer, and quieter place, a world built exclusively from the first two words it ever learned how to speak. The story of stars is the story of how the universe took these two simple ingredients and, through an extraordinary process of cosmic alchemy, learned how to create everything else. There is something deeply peaceful about this. It reminds us that all great things have simple beginnings. The most magnificent and complex structures are built from the humblest of materials. The universe did not need a vast and complicated toolkit to begin its journey of creation. It needed only hydrogen, helium, and the patient, guiding whisper of gravity. And as that gentle whisper continued its work, gathering these simple elements together, the formless, monochrome mist began to weave itself into something with a shape, a name, and a destiny. It was becoming a cradle for something new, and so gravity's patient whisper continues its work, shepherding the thin, invisible mist of hydrogen and helium into something new. The process is unimaginably slow, a great cosmic exhalation that lasts for millions of years. The gas, once spread so thinly you could not see it, is now gently coaxed together, becoming denser and more substantial. And as it gathers, a beautiful transformation occurs. The space that was once transparent, a clear window to the distant stars beyond, begins to grow cloudy. A shadow is being cast in the heart of the cosmos. This is the birth of what we call a molecular cloud. Imagine you are floating just at its edge. Before you is not a place of terror, but one of profound and peaceful darkness. It is a vast silhouette against the glittering backdrop of the galaxy, a serene and silent island in the celestial sea. This cloud is so immense that light itself would take hundreds of years to cross from one side to the other. It is a place of incredible cold, just a few degrees above the impossible stillness of absolute zero. This deep cold is essential. It is a cosmic quiet that calms the atoms, slowing their movement and allowing gravity's gentle whisper to be heard without resistance. The cloud does not churn or boil. It hangs in the darkness, a vast tranquil reservoir of potential. This is the universe's own quiet nursery. It is not a place of emptiness, but a place of profound fullness, a womb where the seeds of thousands of future stars are now held in a deep and patient slumber. When early astronomers looked at these dark patches in the sky, they called them holes in the heavens, believing they were windows into a true and utter void. It was only much later, with instruments that could see the faint signatures of hidden warmth, that we realized the truth. These were not holes at all, but the very opposite. They were the cradles, the fertile grounds, the dark, rich soil from which new light would one day grow. They are places of becoming. In other words, the universe is creating pockets of profound stillness, places where the frenetic energy of the cosmos is hushed, allowing for the delicate and focused work of creation to begin. Within these dark, cold walls, the simple atoms of hydrogen, which have drifted alone for eons, are now close enough to find each other, pairing up to form simple molecules. The cosmic mist is becoming a true, tangible substance, a vast and waiting cloud, pregnant with the promise of 1,000 suns. It is a testament to the universe's patient artistry, the ability to take the simplest ingredients, and with only time and a gentle persistence, weave them into a structure of breathtaking scale and quiet purpose. The immense and tranquil darkness of this nursery is a necessary pause, a deep and settled peace before the next great act. For in the very heart of this profound cold, the relentless and gentle pressure of gravity is beginning to awaken a new and ancient feeling. In the deepest, densest heart of that vast, dark and silent nursery, gravity's whisper is no longer a gentle suggestion. It is a focused and insistent call. Here, in the core of the cloud, the great gathering accelerates. The slow, patient drift becomes a steady, inexorable infall, a silent cosmic waterfall of gas and dust spiraling toward a common center. As more and more material arrives, the core becomes a distinct object, a spinning, contracting sphere of gas, pulling the cloud in around it like a soft, dark blanket. This is the birth of a protostar. It is not yet a star, but it is the living embryo of one. And for the first time in this long story, a new sensation enters our journey, the first stirrings of warmth. Imagine you are standing outside on a clear, freezing winter's night. The air is so cold it feels sharp, and your hands are numb, all feeling seemingly lost to the deep chill. You bring your palms together. At first there is nothing but the press of cold skin against cold skin. But then you begin to rub them together, gently at first, and then with more pressure. A miracle begins to happen. A deep internal warmth starts to bloom in your hands. It is not a fire, not a light, but a comforting, spreading glow of your own making. This warmth comes from friction, from the pressure you are applying, from the simple act of motion and compression creating heat. This is precisely what is happening in the heart of the collapsing cloud. The trillions upon trillions of hydrogen molecules and dust grains are our two hands. As they fall inward, drawn by the immense pressure of gravity, they rub against each other. They collide, they are squeezed together ever more tightly. And in this great cosmic compression, a gentle warmth is born. It is the universe's own version of rubbing its hands together against the cold. The protostar begins to glow, not with the brilliant visible light of a true star, but with a faint, deep infrared blush, the color of warmth itself. If you could see it with eyes sensitive to heat, it would appear as a single, beautiful cosmic ember, glowing softly in the heart of the immense darkness. What this really means is that the universe is storing energy. The immense potential energy of the vast, spread-out cloud is being converted into thermal energy as it collapses. The fall is being transformed into heat. This protostar is a temporary vessel for that energy, a glowing memory of the cloud it once was. It is a moment of profound transition, a bridge between the cold, diffuse past and the fiery, brilliant future. It is no longer a cloud, but it is not yet a star. It is a promise, a question that the universe is asking itself. Is there enough mass? Is there enough pressure? Can this gentle, passive warmth, born only of collapse, be transformed into an active, self-sustaining fire? This is a quiet, beautiful phase of becoming. The protostar will continue to gather material for hundreds of thousands of years, growing denser, heavier, and hotter. It is a celestial infant, swaddled in the dark blankets of its parent cloud, slowly gathering the strength it will need to ignite and begin its true life. For now, it simply exists in this warm, gentle state, a point of growing heat in an ocean of profound cold. But this warmth, born only from the crush of gravity, is a finite thing. For this growing heart to become a true star, it must learn to create its own endless light from within. A threshold is approaching, a point where the pressure itself must unlock a far deeper source of fire. The gentle warmth of the protostar, born from the simple friction of its own collapse, is a beautiful and temporary thing. It is the warmth of a memory, a fading echo of the vast cloud that gave it birth. But gravity is relentless. It is not satisfied with this passive heat. It continues to squeeze, to compress, to add more and more weight to the growing sphere. The protostar's core, once merely warm, now grows hot, and then hotter still, as millions of years of infalling gas press down upon it with an almost unimaginable weight. We are now approaching a threshold, a moment of profound transformation, where the old rules of the universe are about to be gently but irrevocably broken. To feel what is happening, imagine yourself not in space, but sinking slowly into the deepest ocean trench on Earth. As you descend, the world of light and color fades away above you. The vibrant blue of the surface water darkens to a deep indigo, then to a soft, perpetual twilight, and finally, to a perfect and total blackness. The sounds of the surface world are gone, replaced by a silence so profound it feels like a presence. But the most powerful sensation is the pressure. It is not a violent or sudden force. It is a steady, encompassing, and absolute weight. You can feel the heaviness of the miles of water above you, a calm, crushing embrace from all sides. This is a pressure that can bend steel, a weight that redefines the very nature of the world around it. Now, take that feeling and multiply it 1,000,000 times, and 1,000,000 times again. This is the state of the protostar's core. It is a place of such extreme pressure that our minds can barely grasp it. The weight of an entire world of gas, quintillions of tons of it, is bearing down on a single tiny point, The temperature here is no longer just warm. It has climbed into the millions of degrees, a heat so intense that the very structure of the hydrogen atoms begins to break down. The electrons are stripped away, leaving a sea of bare protons, the naked hearts of atoms, all moving with furious speed in a space that is becoming impossibly small. What this really means is that gravity has created a cosmic crucible. It has brought these protons, the fundamental building blocks of the universe, into a forced and intimate closeness they were never meant to experience. According to the laws of physics, these protons should never touch. They each carry a positive electrical charge, and just like the two positive ends of a magnet, they repel each other with a powerful and fundamental force. The closer they get, the more fiercely they push each other away. The core of the protostar is now a place of perfect and extreme tension, the irresistible, crushing force of gravity pushing inward, and the defiant, powerful force of electromagnetism pushing outward. For thousands of years, the protostar exists in this state of exquisite, high-stakes balance, getting ever hotter, ever denser. The battle between these two fundamental forces rages in the silent, superheated darkness of its heart. But this is a battle that gravity, with its patient and overwhelming weight, is destined to win. The core is approaching the magic number, the critical temperature of 15 million degrees. At this point, the protons are moving so fast and are squeezed so tightly together that the force of their repulsion is finally and beautifully overcome. But the next step is not the violent explosion you might imagine. It is the beginning of a quieter, more stable, and far more powerful kind of fire. When the two protons finally touch, their union is not a collision, not a crash, not an explosion. It is something far more elegant and profound. It is a moment of becoming. The immense pressure of the protostar's core has done the impossible. It has overcome the fundamental force of repulsion, and in the silent, superheated darkness, two things have become one. In this union, a tiny fraction of their combined mass, an infinitesimal amount, simply vanishes. It ceases to be matter, and in its place, a small, perfect pulse of pure energy is born. A single photon, a particle of light, springs into existence. This is the moment a star truly ignites. This is the gentle, steady hum of nuclear fusion. Imagine you are in a vast, dark and silent cathedral, a space so large it feels like the cosmos itself. In the very center, two tiny identical tuning forks are floating. They vibrate with a fierce energy that keeps them apart, humming with a tense, dissonant note of repulsion. An immense, invisible and gentle pressure begins to squeeze them together, and the hum of their resistance grows louder and higher. Then, at a certain point, the pressure becomes too great to resist, and they touch. The moment they make contact, they do not shatter. Instead, they merge into a single, new, more stable tuning fork, and all the tense, resistant energy they once held is released in an instant, not as a crash, but as a single, pure, resonant tone that expands outwards, filling the entire cathedral with a deep, warm, and unwavering sound. That sound is energy. That sound is light. This is what is happening in the core of the newly born star. Trillions upon trillions of times every second, protons are gently forced together, merging to become the nuclei of helium, and with each union, a tiny bit of matter is transformed into a pure note of energy. This is not a chain reaction of explosions like a bomb. It is a smooth, continuous, and self-sustaining process. The energy released by one fusion creates the perfect conditions of heat and pressure for the next one to occur. The star has lit its own internal pilot light. It is no longer just a passive sphere glowing with the memory of its collapse. It has found its own voice, a steady internal hum that will now sing for billions of years. What this really means is that the star has become a perfect engine of creation. It has learnt the universe's most profound secret, that matter and energy are two forms of the same thing. The star is now a place of alchemy, calmly turning the simplest element, hydrogen, into the next, helium, and in doing so, it taps into a source of energy, so vast it is nearly limitless. For centuries, brilliant minds on Earth looked at our own sun and were baffled by its endurance. They knew that if it were a great fire made of coal or wood, it would have burned out in a few thousand years. The discovery of fusion was a moment of quiet, human awe, the realization that the sun wasn't asterisk burning, asterisk at all. It was transmuting, creating light from substance, in a process of unimaginable grace and power. This steady internal hum of fusion now creates a new and powerful force. It is an immense wave of light and heat, constantly pushing outward from the core. It is the star's own breath, pushing back against the relentless, crushing weight of gravity that is still trying to squeeze it into nothingness. And in the interplay of these two great cosmic forces, the star finds a perfect and lasting balance. The steady hum of fusion creates a new and powerful presence in the heart of the star. It is a constant, gentle, and irresistible outward push. An immense pressure of light and heat, born in the core, now radiates in every direction, seeking to expand, to push the star's own substance away into the cosmos. At the very same moment, the immense weight of the star, the force of gravity that first brought it into being, is still whispering its single relentless message. Collapse. It is still trying to squeeze the star into an ever smaller, ever denser point. The star is now caught between these two profound and elemental forces, a journey inward toward infinite density and a journey outward toward diffuse dispersal. And in the middle, it finds a perfect and lasting balance. Imagine a master glassblower in a quiet, darkened workshop. The only light comes from the glowing orange mouth of the furnace. She pulls a long pipe from the fire, and on its end is a glowing, molten orb of glass, the color of honey and sunlight. Gravity immediately begins its work on this orb. It wants to pull the liquid glass downward, to make it sag and drip, to lose its beautiful spherical shape and become a formless puddle on the floor. But the artist is calm. She brings the pipe to her lips and begins to breathe. It is not a hard or violent breath, but a steady, gentle and continuous stream of air. This gentle outward pressure from her lungs pushes against the inner surface of the glass, counteracting the inward pull of gravity. The result is a moment of exquisite tension, and a perfect shimmering sphere is held in shape, glowing in the darkness. This is the life of a star. The molten glass is the star's own superheated gas. The patient, relentless pull of gravity is the sag, and the steady, gentle breath of the artist is the constant outward pressure of nuclear fusion. The star's surface is the point where these two forces meet in perfect equilibrium. The inward crush of gravity is precisely, beautifully, and perfectly matched by the outward push of fusion. This state of balance is what defines a star. It is the secret to its long, stable, and peaceful life. It is not a chaotic, raging inferno. It is a celestial object in a state of perfect and serene composure, a sphere of fire held in a delicate cosmic dance with itself. There's a quiet poetry to this idea, first pieced together by astronomers like Arthur Eddington, not in a loud laboratory, but in the quiet contemplation of numbers and observations. It was the realization that the sun was not a thing, but a process. It was a self-regulating system of breathtaking elegance. If gravity were to squeeze the star a little too hard, the pressure in the core would increase, speeding up the rate of fusion. This would create more outward pressure, causing the star to expand, cool slightly, and return to its perfect size. If the fusion were to push a little too hard, the star would expand, the core would cool, and the rate of fusion would slow down, allowing gravity to pull it back to equilibrium. What this really means is that for billions of years, a star is a living performance of balance. It is a conversation between the universe's desire to gather and its desire to radiate. It has found the perfect middle ground, a state of being that is neither collapsing nor dispersing, but simply is asterisk. It will hold this form, this size, and this brightness with an almost unbelievable consistency for eons, a steady and reliable beacon in the cosmic ocean. It is no longer an infant protostar, and it is not yet a dying ember. It is a star in the long, quiet, and peaceful afternoon of its main sequence life. This quiet equilibrium is the essence of a star, the secret to its long and steady life. But the light born in its heart is still deep inside. It must now begin the first and longest journey of its existence. The single perfect pulse of energy born from fusion, a new photon, springs into existence in the star's core. It is a particle of pure light, and it begins its journey traveling at the absolute, universal speed limit. Your first thought might be that this photon will simply fly straight out of the star, arriving at the surface in a matter of seconds to begin its voyage into the cosmos. But the reality is far stranger, far slower, and far more beautiful. The core of a star is not a hollow, transparent chamber. It is the densest, most crowded place imaginable, a substance 100 times denser than lead, a place where trillions of atomic nuclei and electrons are packed together in a superheated, chaotic dance. The newborn photon has not been born into an open sky, but into the heart of an impenetrable storm. Imagine yourself as a tiny, brilliant spark of light in the center of the world's densest and most labyrinthine forest. The trees, the atomic nuclei, are packed so tightly together there is no clear path between them. Their branches and leaves, the swarming electrons, create a thick, shimmering canopy that blocks all sight. You move at an impossible speed, but you can only travel for a fraction of an inch before you collide with a particle. The moment you strike it, you are absorbed, and your energy is held for a fleeting instant. Then, you are re-emitted, sent flying off in a completely new and random direction. You might travel left or right or up or down. You might even be sent backward in the direction from which you just came. This is the journey of a photon out of a star's core. It is a staggering, chaotic, and almost endless series of absorptions and re-emissions. It is less a journey and more a random walk. For thousands upon thousands of years, the photon stumbles through the star's interior, a drunken sailor in an infinitely crowded room. It makes progress not through a determined flight, but by pure statistical chance. After 1,000,000 random collisions, it might find itself a few inches farther from the core. After 1,000,000,000 more, perhaps a few feet. There is no memory of the journey, no desired destination, only an endless random dance in the dark, a ricochet from one particle to the next, for a span of time that defies human comprehension. What this really means is that the light that shines from a star is ancient. The energy that warms your skin on a summer's day was not created 8 minutes ago when it left the sun's surface. That energy began its journey from the sun's core long before the first pyramids were built on Earth, before the last ice age had ended, perhaps even before modern humans had learned to write. For anywhere from 100,000 to 1,000,000 years, that single spark of energy stumbled and staggered its way through the star's dense interior, its original identity lost and reborn in countless interactions. It is a moment of quiet awe to feel the sunlight on your face and to realize you are connecting with a process that is hundreds of thousands of years old. The star's core is a place of instant creation, but its light is a patient messenger, carrying a story that began in the deep past. Eventually, after an eon of this chaotic journey, the photon finally reaches a region where the star becomes less dense. The trees in the forest begin to thin out, the path becomes clearer, and then, at last, it reaches the surface, the boundary between the star and the universe. Here, nothing stands in its way. In a single glorious instant, it is free. It leaps from the star's surface and begins its true journey, a straight and uninterrupted flight across the vast, clear ocean of space. It joins a constant, steady and brilliant stream of countless others, a river of light that flows from the star in all directions, and that steady, quiet stream of light marks the beginning of the star's long, peaceful afternoon, a period of stability that will last for billions of years. With its inner fire now lit, and its form held in a perfect shimmering balance, the star settles in for the longest and most peaceful chapter of its entire existence. This is the era that astronomers, with a simple and elegant turn of phrase, call the main sequence. It is the star's long, quiet and stable adulthood. For billions upon billions of years, it will exist in this state of serene equilibrium, a steady and unwavering beacon in the cosmic dark. Imagine a perfect summer afternoon, one so calm and so peaceful that time itself seems to slow down and stretch. The sun hangs high in a cloudless blue sky, and it does not seem to move. The air is warm and still. The only sound is the gentle, distant hum of a world at peace. There is no drama, no urgency, no sense of a beginning or an end. There is only a feeling of profound and lasting presence. This is the main sequence life of a star. It is the long golden afternoon of the cosmos. For a star like our sun, this afternoon will last for 10 billion years, a span of time so vast that the entire history of humanity is but a single fleeting heartbeat within it. During this time, the star's job is simple. It has one purpose, which it performs with a quiet and beautiful consistency, to fuse hydrogen into helium in its core. It is a slow, methodical, and incredibly efficient process. The star sips its vast reservoir of fuel, never rushing, never wasting. The perfect balance between the outward push of this fusion and the inward pull of its own gravity holds it in a state of unwavering stability. Its size will not change. Its temperature will not change. Its brightness will remain a constant, gentle glow for eons. When we look up at the night sky, the vast majority of the stars we see are in this calm and steady phase of their lives. They are the quiet, reliable citizens of the cosmic city. In other words, a star on the main sequence is not a chaotic explosion or a fleeting event. It is a bastion of predictability in a universe that can often feel random and violent. It is a source of constancy. Our own sun is the most intimate example of this. For 4.5 billion years, it has been in its own quiet afternoon, providing the steady, reliable light and warmth that have allowed for the slow, patient miracle of life to unfold on our world. It is a quiet parent, a dependable furnace, a cosmic metronome whose steady beat has governed the rhythms of our planet for its entire history. There is something deeply reassuring in this idea that the very heart of our solar system is a place of such profound and lasting peace. This tranquil state is the main story for almost every star, the central chapter that makes up the bulk of its biography. But the star is not a perfectly sealed container, a self-contained island of light. Even in this state of perfect balance, it is connected to the space around it in a subtle but powerful way. It has a breath. However, a softer clue nudges us further. The star breathes out a quiet and constant sigh, a stream of its own substance that flows out into the dark. Even in this long, quiet afternoon of its life, the star is not a static or isolated object. It is a living, breathing entity, and like all living things, it has a breath. It is not a breath of air, of course, but a constant, gentle, and almost invisible stream of its own substance that flows outward into the cosmos. Astronomers call it the stellar wind. It is a quiet and persistent sigh that travels for light years in every direction, a subtle but powerful presence that shapes the entire region of space around the star. To understand this, imagine you are standing by the shore of a perfectly calm and glassy lake on a summer morning. The air is still, and the water is a perfect mirror of the sky. Then, a single gentle breeze begins to blow from across the lake. It is not a storm, not a gale, but a steady, soft, and continuous whisper of air. You can't see the wind itself, but you can see its effect. The perfect glassy surface of the lake is replaced by 1,000,000 tiny shimmering ripples, all moving in the same direction. The wind is a quiet, invisible hand, stroking the surface of the water, transferring its own gentle energy to everything it touches. The stellar wind is the universe's version of this gentle breeze. The star's immense heat and energy are constantly agitating its own outer layers, occasionally giving individual particles, protons, electrons, the very stuff of the star itself, enough of a kick to escape its gravitational pull. They are not violently ejected. They are gently lifted away, like tiny specks of dust carried on a warm updraft. This creates a continuous, high-speed flow of particles, a celestial breeze that leaves the star's surface and journeys out into the solar system. It is the star's own atmosphere, becoming unbound and venturing out into the ocean of space. For a star like our Sun, this wind is a delicate thing. In the grand scheme of the star's total mass, the amount it loses through this wind is tiny, an insignificant fraction over its entire lifetime, but its effect on the space around it is profound. This is the wind that creates the beautiful, ethereal tails of comets, pushing their vaporized ice and dust away from the sun like cosmic weather vanes. It is the wind that carves out a vast protective bubble around our solar system, a magnetic shield called the heliosphere that deflects the harsher radiation from deeper in the galaxy. It is the star's breath, creating a safe and sheltered harbor in the vastness of space. What this really means is that a star is not just a distant point of light. It has a sphere of influence, a tangible presence that extends far beyond its visible surface. The space between the planets in our solar system is not an empty vacuum. It is filled with the sun's own breath, a constant streaming outflow of itself that touches and shapes everything within its reach. There is something quietly intimate about this. When we stand outside under the open sky, we are not just receiving light from the sun. We are standing in the outermost reaches of its own being, bathed in a gentle, invisible wind that has traveled 93 million miles to reach us. This stellar wind is a beautiful expression of the star's calm and steady life. But this constant outflow of warmth creates something even more consequential for the worlds that orbit it. It sets the stage for a region of gentle, life-giving heat, a cosmic campfire that creates the perfect conditions for a world like our own to exist. That steady, patient breath of light and warmth, flowing from the star, creates a profound and life-giving consequence for the worlds that may be circling it. In the cold, silent ocean of space, the star acts like a gentle and constant campfire. Very close to the fire, the heat is overwhelming, a place where no world could survive without being scorched. Far, far away from the fire, its warmth fades to almost nothing, and any world out there would be a frozen, forgotten island of ice. But in between these two extremes, there exists a perfect, gentle and temperate ring of warmth. It is a region of space that is not too hot and not too cold, a place where a planet could exist that is just right for one of the most precious and delicate substances in the universe, liquid water. Imagine you are camping in the deep, profound stillness of a desert night. The air is cold, and the sky is a brilliant tapestry of stars. At the center of your camp is a crackling fire, the only source of warmth in the vast, cool darkness. You pull your chair closer to it. Too close, and the heat is uncomfortable on your face. The flames too bright and fierce. You move your chair back. Too far, and the cold of the desert begins to creep back into your bones, and the fire becomes just a distant, flickering light. But then, you find the perfect spot. It is a magical distance where the gentle, radiant heat is just enough to keep you perfectly warm, where you can feel the life of the fire without being overwhelmed by it. You are in the campfire's own habitable zone. This is precisely what a star creates in the space around it. Astronomers call this region the Goldilocks zone, and it is the most sought-after piece of real estate in the entire cosmos. It is the narrow orbital band where a planet's surface temperature would be just right for water to exist in its liquid state, to form oceans, rivers, and clouds. And liquid water, as far as we know, is the essential ingredient for life, the universal solvent where the complex chemistry of biology can begin its slow, patient dance. A star's habitable zone is a quiet cosmic garden, a temperate island in the vast, cold ocean, where the seeds of life might have a chance to grow. What this really means is that a star's purpose is not just to shine, but to create the conditions for other, more complex stories to begin. It is a source of potential. It gently warms the surfaces of its planetary companions, providing the stable, long-term energy source that life needs to emerge and evolve. The 10-billion-year quiet afternoon of a main-sequence star is the perfect long and lazy summer that biology needs to perform its slow and patient miracles. The star becomes a celestial parent, creating a safe, warm and stable home for its family of planets. There is a deep and beautiful sense of purpose in this. The star is not just an isolated object, but the life-giving heart of a whole system of worlds. For much of human history, we looked at the stars and wondered if we were alone. The discovery of this simple, elegant concept, the habitable zone, was a profound turning point. It transformed the stars from simple points of light into potential campfires, each one a possible center for a world like our own. The night sky was no longer just a beautiful, empty vista. It became a forest of 1 billion potential gardens, each one warmed by its own quiet and steady sun. But not all of these campfires are the same. The size and heat of the fire determines everything about the garden around it, and this simple difference creates a forest of countless, wonderfully different trees. Not all of these stellar campfires are created equal. The single, most important trait of a star, the one that will write its entire destiny from its first breath to its last, is its mass. The amount of matter it gathers in its cradle determines everything: how hot it will burn, how brightly it will shine, how long it will live, and how it will ultimately die. To understand this, let us leave the desert campfire and step into a vast, silent, and cosmic forest. This forest is our galaxy, and every tree within it is a star. As you walk through this forest, you see a breathtaking diversity. All around you are the most common trees, small, gnarled, and ancient-looking things that grow low to the ground. They are like cosmic bonsai trees, their bark a deep, dim red, like the color of a fading ember. These are the red dwarf stars. They are the least massive stars, and because their weight is small, the gravitational pressure in their cores is gentle. They do not rage with fire, they smolder. They sip their vast reserves of hydrogen fuel with an almost unbelievable frugality. burning through it so slowly that their lives will last not for billions, but for trillions of years, far longer than the current age of the universe. They are the quiet, patient, and enduring spirits of the forest, and they will still be glowing softly long after every other light has gone out. Then, your gaze is drawn upward to a sight of breathtaking and terrifying beauty. Towering over everything else in the forest is a colossal tree of brilliant, searing blue-white light. It is like a cosmic sequoia, a pillar of pure energy that floods the surrounding woods with its intense glare. This is a blue giant, a star born with dozens, or even hundreds of times the mass of our sun. This immense mass creates a gravitational pressure in its core that is almost unimaginably violent. It does not sip its fuel, it guzzles it, burning through its hydrogen in a furious, brilliant, and profligate blaze. Its life is a spectacle of power and light, but it is a life that is destined to be tragically short. It will exhaust its fuel in just a few million years, a mere cosmic heartbeat, and its death will be as spectacular as its life was brilliant. And what of our sun? In this forest, our sun is a familiar, sturdy, and welcoming oak tree. It is not the grandest, nor the most ancient, but it is strong, stable, and life-giving. It provides a warm and gentle light, a constant and dependable presence that has allowed for a complex and beautiful ecosystem to flourish beneath its branches. What this really means is that a star's mass dictates its metabolism. A more massive star has far more fuel, but it lives a much shorter life. This is the central, beautiful paradox of stellar evolution. The very weight that gives it such a vast reserve of hydrogen is also what forces it to burn through that fuel at an exponentially faster rate. The life of a star is a perfect illustration of the old proverb, "The flame that burns twice as bright burns half as long." For decades, astronomers patiently catalogued the stars. People like Annie Jump Cannon and the team of women at Harvard, who in the late 19th and early 20th centuries meticulously classified the spectra of hundreds of thousands of stars. It was this quiet, patient work of classification that first revealed this deep and elegant truth, turning a seemingly random scattering of lights into an ordered, understandable family portrait of the cosmos. This profound difference in their inner lives, in the very speed at which they experience their existence, is not a hidden secret. It is written across the night sky for all to see. The light from these different stars carries a quieter message, one that speaks directly to the nature of their fire. The fiery, brilliant life of a massive star and the slow, smouldering existence of a small one are not hidden secrets. The universe does not keep this information locked away. Instead, it broadcasts this truth across the cosmos, written in the simplest and most beautiful language imaginable, the language of color. The light that reaches our eyes from a distant star carries with it a quiet and elegant message, a direct report on the temperature of its surface. To understand this, let us return one last time to that quiet, dark room, sitting before a fireplace where a great log fire is now slowly, peacefully coming to the end of its life. Earlier in the evening, when the fire was at its peak, the flames were a brilliant, almost white-hot yellow, and in the very heart of the logs, you could see flashes of intense, searing white light. The heat was so strong it pushed you back, a powerful, radiating presence in the room. This is the light of a young, massive star, a brilliant blue-white fire that burns with an incredible intensity. Now, hours later, the fire has settled. The roaring flames are gone, replaced by a deep, comforting and steady glow. The logs are a solid mass of burning embers, radiating a warm, welcoming orange and yellow light. This is the fire of a star like our sun, in the long, stable afternoon of its life, a perfect and sustainable warmth that gives life rather than overwhelms it. And now, as the night draws to a close, you watch as the embers begin their final slow fade. The bright orange softens to a deep, dark cherry red. The light is now dim, and the heat is a gentle, fading memory. You can draw close now, feeling the last of its life radiate into the cold night air. This is the light of a red dwarf, or an ancient dying star, a cool and gentle glow that speaks of an immense and quiet age. This simple, peaceful truth of the cooling ember is a universal law. The color of a glowing object is a direct measure of its temperature. It was a truth first pieced together in the quiet labs of the late 19th century by physicists like Wilhelm Wien, who discovered that the hotter an object is, the bluer the light it emits. It was a moment of profound connection, The realization that the same physical law that governs the color of a hot piece of iron in a blacksmith's forge is the very same law that paints the stars in the night sky. The universe, it turned out, speaks the same simple language everywhere. What this really means is that the night sky is a vast cosmic thermometer. Each star is telling you its temperature, whispering its secret across light years of empty space. The piercing blue-white of Sirius is the universe telling you of its immense heat. The soft ruby red of Betelgeuse is the universe speaking of a cooler, more ancient surface. And the familiar, gentle yellow of our own sun is the color of a perfect, life-giving warmth. The beautiful and varied colors of the stars are not random, not an aesthetic choice by the cosmos. They are a direct and honest advertisement of their own inner nature. The color tells the story of the star's surface with perfect clarity, a simple and beautiful truth written in light. But this visible light is just the skin of the truth. For deep inside, the star is humming with a silent music, carrying a message from its hidden core. The simple, beautiful language of color tells us the story of a star's surface, a truth written in a language of embers. But there is a deeper story, a more subtle and profound message, coming from a place we can never see, the star's hidden heart. The star in its long and quiet life is not silent, it is humming. It is filled with a deep, silent music, the vibrations of its own inner existence. And if we learn how to listen, this music reveals everything about its hidden world. Imagine once again that you are floating in a vast, dark and silent cathedral of space. Hanging before you is not a star, but an immense cosmic bell. It is made of a substance that shimmers with a soft internal light, and it is so large that its edges fade into the darkness. It hangs in a state of perfect and profound stillness. Then, from deep within the bell, a soft, continuous, and almost imperceptible force begins to tap it. It is not a single sharp strike, but a constant, gentle, and rhythmic pushing, like the soft patter of a million raindrops. This is the star's own internal energy, the constant roiling and churning of the gas deep within it, a process called convection. As this gentle internal tapping continues, the bell begins to vibrate. It does not ring with a loud, sharp clang, but with a deep, resonant, and incredibly complex hum. It is a sound so low and so powerful you would feel it in your bones rather than hear it with your ears. This single, complex chord of sound is the star's own silent music. And just as the sound of a real bell tells you everything about it, its size, its thickness, its shape, what it is made of, this stellar hum is a perfect autobiography of the star's interior. This is the beautiful science of asteroseismology. The starquakes are the constant vibrations rippling through the star. These sound waves travel from the core to the surface, causing the star's outer layer to gently pulse, to move in and out by a tiny, almost immeasurable amount. This gentle, rhythmic breathing causes the star's light to fluctuate, to dim and brighten by just a few parts per million. For decades, this was a beautiful but unprovable theory. Then we built instruments of incredible sensitivity, space telescopes like Kepler and TESS, which were essentially cosmic ears. They could stare at a single star patiently for years at a time, and they could hear it. They could detect that faint rhythmic change in the starlight, and for the first time, we could listen to the music of the suns. What this really means is that every star is a musical instrument, and it is constantly playing the song of itself. It is not a simple song with a single note, but a rich and complex symphony of 1,000 different overlapping frequencies and rhythms. By carefully listening to this symphony and untangling its harmonies, we can measure the unseeable, we can determine the density of its core, the exact location of different layers within it, and even, with breathtaking precision, its true age. We are listening to the echoes from the very heart of a star, turning its light into a sound that tells us its most intimate secrets. The song it sings now is the song of its long and stable middle age, a steady and harmonious chord held for billions of years. But if we could listen with the patience of the cosmos itself, we would realize that this perfect harmony cannot last forever. The very fuel that sustains this beautiful note is, after all, finite. The beautiful, complex song the star sings is the music of its long and stable life. It is a chord of perfect harmony, held for billions of years in a state of serene and unwavering balance. But nothing in the universe, not even a star, can hold a single note forever. The vast reservoir of hydrogen fuel in its core, which once seemed truly infinite, is a finite resource. After eons of steady, patient fusion, the star's long summer afternoon is inevitably, peacefully, drawing to a close. Imagine you are standing in a golden meadow at the very end of August. For months, the days have been long and warm, a seemingly endless season of light. But now, for the first time, you can feel a subtle change in the air. The sun is still warm on your skin, but it hangs a little lower in the sky, and its light has softened from a brilliant white to a deep honeyed gold. The shadows cast by the trees are growing longer, stretching out like quiet, sleepy fingers across the fields. The vibrant green of the leaves is still there, but it is touched with a new sense of tiredness, a hint of the fiery colors that are to come. A gentle, cooler breeze stirs, a first quiet whisper of the autumn that is waiting just over the horizon. This is the state of the aging star. It is not a sudden or violent change. It is a slow, graceful, and inevitable transition. For billions of years, it has been steadily turning the hydrogen in its very heart into helium. Now that process is nearly complete. The core of the star, the very center of its furnace, is no longer a roaring fire of hydrogen fusion. It has become a dense, quiet sphere of helium ash. The main engine in the heart of the star has sputtered and grown quiet. The song, for a moment, has gone silent. For so long, the story of the star was the story of a perfect balance. The outward push of fusion was the perfect answer to the inward crush of gravity. But now, with the fire in the very center extinguished, that balance is broken. Gravity, the patient gatherer, the quiet sculptor that first brought the star into being, has not gone away. It is still there, whispering its constant message of collapse. And with the outward pressure from the core now gone, there is nothing left to resist it. For the first time in billions of years, gravity begins to win. What this really means is that the star's life support system is beginning to fail in a very specific and profound way. The star is not running out of all its hydrogen, far from it. The vast majority of the star is still made of pristine hydrogen fuel, but the conditions for fusion, the intense heat and pressure, only exist in the very core, and it is precisely this critical central region that has now been exhausted. It is like a great and ancient tree whose deepest roots have finally stopped drawing water, even as its high branches are still green. It is the beginning of a slow, inevitable, and magnificent decline. The quiet, patient work of generations of astronomers, charting the lives of stars, led to this gentle, poignant realization that stars are not eternal. They are mortal. They have a lifespan, a story with a beginning, a middle, and an end. And the end of their long, peaceful summer is not a sudden darkness. It is the start of a final, glorious, and transformative autumn. But the next step in this journey is a quiet paradox. As gravity begins to crush the now silent helium core, the star itself will not shrink. It will begin a slow, majestic, and final expansion. With the fire in its heart now extinguished, the star's core begins to collapse under the immense, patient weight of its own gravity. This new inward crush on the silent sphere of helium ash creates a paradoxical and beautiful effect. The core itself shrinks and grows fantastically hot from the compression, hotter even than it was when it was alive with fusion. But the star as a whole does not shrink with it. Instead, it begins a slow, magnificent and final expansion, a great calm exhalation that will last for millions of years. This is the star's transformation into a red giant. Imagine an old blacksmith working late into the evening in a quiet, dusty forge. The fire in the center of his hearth, a bed of fine coal, has been burning steadily all day, a compact and brilliant white-hot heart. But now, the best of the coal has been consumed, and the core of the fire is nothing but a bed of grey, exhausted ash. Gravity is the weight of the cooling air, settling down on the hearth, trying to snuff it out. The blacksmith, needing to heat one last piece of iron, knows he cannot reignite the dead center. Instead, he takes up his great bellows and begins to pump, not at the center, but around its edges. He is forcing a furious blast of air onto the ring of fresh, unburnt coal that surrounds the dead core. The effect is dramatic. The ash in the center does not catch fire, but the ring of coal around it erupts in a desperate, brilliant blaze. This new fire is wider and less focused than the old one, and it produces a tremendous wave of heat that pushes outward. The fire swells to an immense size, no longer a compact white heart, but a huge, billowing, and much cooler flame of deep orange and red that fills the entire hearth and pushes the blacksmith back with its sheer radiant size. This is the star in its red giant phase. Its heart is dying, but its outer layers are engaged in a final glorious flare-up. The collapsing helium core is the bed of ash, growing ever hotter under its own weight, but inert. The shell of pristine hydrogen just outside this core is the ring of fresh coal. The intense heat radiating from the collapsing core acts as the blacksmith's bellows, igniting this shell in a furious new round of fusion. This shell burning phase is far more intense and generates more total energy than the star's original stable state. This tremendous new outward push of energy completely overwhelms the star's gravity, causing its outer layers to swell to a size that is almost impossible to comprehend. For a star like our Sun, its surface will expand 100 or even 200 times its original size, swallowing Mercury, Venus, and perhaps even the Earth. What this really means is that the star has entered a profound state of imbalance. It is a star at war with itself, dying at the center and raging on its surface. It becomes a beautiful, luminous, and ethereal ghost of its former self. Its surface, now spread over such a vast area, cools down, glowing with the deep, cool, and gentle red of a cosmic ember. It is a final, spectacular, and poignant gesture, a last, deep, and steady breath. This will be the fate of our own Sun, 5 billion years from now. It is not a violent or sudden end, but a slow, majestic, and inevitable transformation into the quiet, ruddy giant that will one day fill our sky. But this great red flame is a temporary fever. Deep within, in the crushed and silent heart of the star, the pressure is building toward a new and even deeper kind of fire. For millions of years, the star's vast red and swollen body has been a magnificent but temporary illusion, powered by a desperate, fleeting fire in a shell around its dying heart. But deep within that heart, the inert sphere of helium ash continues to collapse, squeezed by a gravitational pressure that never sleeps. The temperature in this core, which has no fire of its own, climbs to an almost unbelievable 100 million degrees. Here, in this silent, superheated prison, the universe is preparing to light a second, deeper, and far more profound fire. Imagine you are standing in a chamber at the very center of a planet, a place of impossible pressure. The weight of 1,000 miles of rock is bearing down on you from every direction. The silence is absolute, and the heat is not a flame, but a deep, penetrating quality of the space itself, a warmth that comes from pure compression. The walls of this chamber are made of a single, uniform, crystalline substance. For eons, it has resisted this pressure, remaining unchanged. But as the pressure continues to build, a quiet miracle begins to happen. The crystals begin to glow with a faint internal light. The very structure of the material is being overwhelmed, and a new energy is being unlocked. The substance is not burning, it is transforming. The rock itself is becoming a source of light. This is what happens in the core of the red giant. The helium nuclei, the ash of the star's first life, are being crushed together with such incredible force that they finally overcome their natural repulsion. In a process of breathtaking elegance, 3 helium nuclei are fused together to become a single, heavier. This is the moment of the helium flash, a silent, internal sunrise. A new sun is born within the old one, a fire not of hydrogen, but of helium. A deeper, hotter, and fiercer blue-white fire now rages in the star's core. This is the universe's great act of alchemy. It has taken the second element and transformed it into the 6th. And carbon is not just another element. It is the backbone of life as we know it. It is the versatile, essential atom that forms the basis of all organic chemistry. In the heart of this aging, dying star, the very seed of life is being forged. The astronomer Fred Hoyle, in a moment of profound insight, realized that for this process to happen, the laws of physics had to be exquisitely fine-tuned. He saw that the universe seemed to have a recipe, a pre-written plan, that allowed for the creation of this life-giving element inside of stars. It was a discovery that felt less like science and more like a quiet cosmic revelation. What this really means is that the star has been given a second lease on life. The new powerful outward push of this helium fusion in the core now counteracts the crush of gravity once more. The star stops its collapse and its expansion, and for a brief new period of stability, it finds its balance again. It has learned how to burn its own ashes, to draw a deeper energy from the remnants of its first long life. It is a beautiful and poignant moment of cosmic recycling, a testament to the universe's refusal to give in to simple decay. But this second life is a brief, intense whisper. The new fire of helium fusion is far more temperamental than the steady hum of hydrogen. The star's vast crimson cloak is now held too loosely by gravity. The next step in this journey is not a new fire, but a final, graceful act of letting go. The second life of the star, burning helium in its core, is a brief and uncertain reprieve. This new, hotter fire is far more unstable than the gentle, steady hum of its youth. The star's vast crimson outer layers, already swollen to an immense size, are now held only loosely by the feeble grip of its gravity. The star has become too large for its own good, a beautiful but fragile ghost of its former self. In its final act, it does not collapse, and it does not explode. It simply lets go. Imagine you are holding a single, perfect dandelion seed head in your hand on a still summer afternoon. It is a complete and beautiful sphere, 1,000 tiny, feathery seeds held together in a delicate and perfect globe. Then, a slow, deep and gentle breeze begins to blow. It is not a violent gust, but a steady, patient exhalation. One by one, the tiny seeds lift from their sphere, released into the wind to begin their own new journeys. The process is one of peaceful disassembly. The beautiful globe does not shatter, it dissolves, gracefully giving its substance back to the air until nothing is left but the tiny bare heart from which all the seeds once grew. This is the final act of a star like our Sun. In its last few 100,000 years, its internal instabilities create powerful periodic pulses, great superwinds, that are like the slow, deep breaths of the summer breeze. With each pulse, the star's outer layers, its vast red atmosphere, are gently pushed away into space. Over thousands of years, layer after layer is shed, a series of concentric, expanding smoke rings drifting away from their parent star. This cloud of gas, containing all the hydrogen and helium the star never burned, as well as the new carbon it forged in its heart, expands outward into the silent, cold ocean of space. When early astronomers like William Herschel first saw these objects through their small telescopes in the 18th century, they saw faint, glowing, circular or oval shapes. They looked to them like the faint, ghostly disks of the newly discovered gas giant planets, and so they gave them a beautiful and misleading name, planetary nebulae. They have nothing at all to do with planets. They are the gentle, beautiful ghosts of dying stars. The cloud of gas itself does not shine. It is illuminated from within, made to fluoresce with breathtaking colors, vibrant greens of oxygen, deep blues of helium, and soft reds of hydrogen and nitrogen, by the intense ultraviolet glare of the tiny, superhot core the star has left behind at its center. What this really means is that the star is not dying in a violent event, but is blossoming one last time. It is an act of supreme and peaceful recycling. The star is returning the majority of its substance back to the interstellar medium, enriching that great cosmic ocean with the heavier elements it has created. This gentle ghost will continue to expand and fade over the next 20 or 30,000 years. Its beautiful, intricate structure, sometimes a perfect ring, sometimes a butterfly's wings, sometimes a haunting cosmic eye, slowly dissolving back into the primordial mist. This beautiful fading cloud is a temporary masterpiece, and at its heart sits the star's final quiet ember. As the beautiful intricate layers of the planetary nebula drift away, dissolving back into the cosmic ocean like a phantom of colored smoke, the star's final hidden secret is revealed. At the very center of the fading ghost sits a tiny, brilliant, and incredibly hot point of light. This is the star's core, the sphere of carbon and oxygen ash that was forged in the heart of the red giant, now laid bare for the universe to see. This is the star's final, quiet ember. This is a white dwarf. Imagine yourself in a vast, dark and ancient forest, long after the last great fire has swept through. The smoke has cleared, the sky is dark, and a profound quiet has settled over the land. You walk through the silent, charred remains of what were once towering trees. Here and there, nestled in the dark, cool ash, you see them. Tiny, almost star-like points of light, glowing with a brilliant, pure white heat. They are the dense, compacted hearts of the ancient trees, the knots of wood so solid that the fire could not consume them. They are no longer burning, no longer producing their own heat, but they are still glowing with the immense stored energy of the great fire they have just endured. They are the forest's cooling embers, and they will continue to shine with this ghostly, residual light for 1,000 years. The white dwarf is the universe's version of this cooling ember. It is one of the most extreme and paradoxical objects in the cosmos. It is the crushed and fantastically dense remnant of a star's heart, an object with the mass of our entire sun, squeezed by gravity into a perfect sphere no larger than the Earth. A single teaspoon of its material would weigh more than a truck. It is a substance so dense it can barely be called matter anymore. It is held up not by the outward push of fusion, for its fires are forever extinguished, but by a strange and powerful quantum law called electron degeneracy pressure. It is a law that simply states that you cannot pack electrons any more tightly together. Gravity has finally been halted, not by a fire, but by the fundamental nature of reality itself. This tiny Earth-sized sphere is at first one of the hottest objects in the universe, with a surface temperature of over 100,000 degrees, glowing with a brilliant blue-white light. This is the light that illuminates the planetary nebula around it. The astronomer Subramanian Chandrasekhar, on a long sea voyage from India to England in 1930, at the age of just 19, did the quiet, solitary calculations that first revealed the true nature of these objects. He realized that a star's final fate was a quiet battle between gravity and the quantum world, and that for stars like our Sun, the quantum world would win, creating these stable, beautiful, and eternal embers. What this really means is that a white dwarf is a perfect and lasting memory. It is a star's gravestone, a silent monument to the long and brilliant life it once lived. It no longer creates new energy. It is simply a cosmic thermos, a perfectly insulated container of heat that will now spend the rest of eternity slowly, patiently, radiating that stored warmth away into the cold of space. Over billions and then trillions of years, it will cool. Its brilliant blue-white will fade to a soft yellow, then to a gentle orange, and finally to a dim, cool red. It is a process of almost infinite slowness, a final, peaceful and graceful fade to black. This is the gentle, quiet end for a star like our Sun, a final, beautiful fade into a long and peaceful twilight. But this is just one path. This is the fork in the road of cosmic destiny. For the giants of the celestial forest, the massive stars, their immense weight means they cannot and will not go so quietly into the night. The gentle, quiet end of a star like our Sun, fading peacefully into a crystalline white dwarf, is a beautiful and common story in the cosmos. It is the story of a gentle stream that, after a long and meandering journey, finally flows into a calm and placid lake, its journey ending in a state of perfect and lasting stillness. But this is only one path, one possible ending written in the stars. There is another, a fork in the cosmic road, and the signpost at this fork is written in a single word: mass. For the giants of the celestial forest, the stars born with 8, 10, or 50 times the mass of our Sun, their destiny does not lead to a quiet lake. Their life is not a gentle stream, but a vast and powerful river, and it is a river that is destined to end in a waterfall of unimaginable grandeur. Imagine you are standing on the bank of this immense river. Its life from the very beginning was different. It flowed faster, its currents were stronger, and it carried a furious energy that carved canyons through the landscape of space-time. This is the life of a massive star, burning through its fuel with a brilliant blue-white intensity, living a glorious and tragically short life of only a few million years. Now, as you stand on its bank near the end of that life, you can feel that the river's character is changing once again. The water is accelerating, the calm surface replaced by a powerful churning surge. You can hear a low, distant roar, a deep and resonant hum that seems to make the very ground beneath your feet vibrate. It is the sound of the falls, the grand finale toward which this entire river has been flowing. This is the state of the aging massive star. It has not just fused hydrogen to helium and helium to carbon. Its immense internal pressure and heat have continued the chain of alchemy, forging ever heavier elements in its core. Carbon into neon, neon into oxygen, oxygen into silicon. In a series of nested shells, like a cosmic onion, the star has spent its short life creating a heart of heavy metallic ash. The final fuel is silicon, and in a last, desperate phase that lasts only for a single day, It fuses that silicon into iron, and with iron, the story stops. Iron is the final ash. No matter how much you squeeze it, no matter how hot you make it, it cannot be fused to create energy. It is the end of the line. The fire in the star's heart, for the last and final time, goes out. The distant roar you heard is the sound of this final silence. What this really means is that gravity is about to achieve its ultimate victory. For a small star, the quantum world provided a firm and unbreakable floor, stopping its collapse. But for a massive star, the weight is too great. The river is too powerful. There is no gentle lake bed for it to settle into. The number that defines this fork in the road is known as the Chandrasekhar limit, a quiet line drawn in the cosmos by the mathematics of a young genius. If the star's remaining core is above this limit, about 1.5 times the mass of our Sun, the quantum floor will break. Gravity will not be stopped. The star's own immense weight will crush it into oblivion. The entire vast river of its being has now reached the precipice. The star hangs there for a single, final, breathtaking instant. Its heart is silent, its fires are dead, and there is nothing left to hold back the weight of its own magnificent, luminous body. The great journey is over, and the fall is about to begin. But the light from this final moment carries one more, extraordinary message. With its heart of iron now silent, the star has reached the end of its long journey. The quantum floor that supported a smaller star has broken, and there is nothing left to halt the final, complete victory of gravity. In a single, silent instant, the star begins to fall inward upon itself. The core, once the size of the Earth, collapses in less than a second. It shrinks at 1/4 of the speed of light, a silent, breathtaking implosion that is the universe's own great intake of breath. The star's outer layers, suddenly finding nothing beneath them, hang for a moment in a state of impossible weightlessness, and then they too begin their long final fall toward the center. Let us return to that immense river, flowing toward the edge of the world. For a single quiet moment, the water reaches the precipice and seems to pause, a perfect smooth curve of liquid stillness against the open air, and then it falls. It is not a chaotic tumble, but a single, majestic and unified plunge into the great abyss below. The entire river, all of its power and all of its substance, is now in a state of silent free fall. This is the collapse of the star, but the abyss is not bottomless. The core of the star does not fall into nothingness. It collapses until it becomes a sphere of pure neutrons, a substance so dense that the universe itself says, "no more." This neutron core is the unyielding stone floor of the cosmic canyon, and when the rest of the stars in falling material, the entire vast mass of that celestial river, strikes this incompressible floor, the result is a rebound of unimaginable power. The waterfall does not just stop, it explodes outward, transformed. The falling water strikes the stone and atomizes into a vast, upward rushing cloud of incandescent mist, a shockwave that tears back out through the very river that is still trying to fall. This is the supernova. For a few brilliant, beautiful weeks, the dying star unleashes a torrent of light and energy that outshines the combined light of the 100 billion other stars in its own galaxy. It becomes a temporary luminous diamond, a beacon visible across millions of light years. It is the universe's grandest finale, a final, spectacular firework celebrating the end of a magnificent life. When the Danish astronomer Tycho Brahe saw such an event in 1572, he saw a bright new star appear in the sky where none had been before. He called it a stellar nova asterisk, a new star, believing he was witnessing a birth. It is a beautiful and poignant irony that what looks to us like the most brilliant of celestial births is, in fact, the glorious and transformative death of a star that has been gone for centuries, its final message only just now reaching our shores. What this really means is that the supernova is not an act of destruction, but one of glorious and ultimate release. The star is giving everything it has back to the cosmos. It is a final, generous exhalation of all the light it ever created and all the substance it ever held. For millions of years, the star was a quiet, stable container of energy. Now, in a single, magnificent gesture, it returns that energy to the universe, a debt repaid in a currency of pure, brilliant light. And this wave of light, this expanding ghost of the star, is not empty. It carries the star's most precious and lasting inheritance, The brilliant, expanding cloud of the supernova is not just an echo of light, it is a messenger cloud, a vast, swirling ghost carrying the star's most precious and lasting inheritance. For its entire long life, the star was a patient and meticulous alchemist, slowly turning the universe's simplest ingredients into heavier and more complex ones. But its creative journey stopped at iron. Iron was the final ash, the end of the line for fusion, and yet our universe is filled with elements far heavier than iron. There is the soft, warm glow of copper, the brilliant gleam of silver, the heavy, reassuring weight of gold and platinum, the dense mystery of uranium. If the star's own fire could not forge them, where did they come from? The answer is that they were born not in the star's life, but in the final, violent and glorious instant of its death. The supernova itself is the cosmic forge. Imagine for one last time that great blacksmith's workshop. The star's iron core is the anvil, a solid, unyielding surface. The star's own collapsing outer layers are the hammer, a blow of unimaginable force. And the supernova shockwave, the rebound from the core, is a flash of heat and energy so intense it is unlike any fire that has ever existed. But most importantly, this shockwave unleashes an incredible dense storm of neutrons. In the frantic, fleeting seconds of the explosion, this is where the final rapid-fire alchemy happens. The iron nuclei on the anvil are bombarded by this torrential flood of neutrons. In a furious, microscopic ballet, they absorb them, one after another, becoming heavy, bloated, and unstable. They then decay into new, stable, and heavier elements. An iron nucleus might catch enough neutrons to become, in an instant, an atom of silver. A moment later, it might be transformed into gold. All the elements of the periodic table that are heavier than iron are born right here in the flash of this cosmic lightning. It is not the slow, patient fusion of the star's heart, but a frantic and instantaneous act of creation, the universe's most violent and most productive workshop. What this really means is that the death of a massive star is the universe's primary act of enrichment. The supernova is not just an explosion, it is the ultimate dispersal event. It is the universe's grand and generous gesture of taking the rarest and most precious materials, forged in the heart of one of its most magnificent creations, and scattering them like seeds upon the cosmic wind. This beautiful, expanding nebula of gas and dust is now laced with gold, silver, oxygen, carbon, and iron, all the ingredients necessary for building new stars, new planets, and perhaps new life. There is a profound and deeply personal truth hidden in this violent cosmic story. Every atom of oxygen you are breathing in right now, the calcium in your bones, the iron in your blood that carries that oxygen to your cells, every single one of those atoms was created in the heart of a massive star and flung out into the cosmos by a supernova explosion billions of years ago. The gold in a wedding ring is not just a symbol of value because it is rare. It is a tiny, glittering fragment of a star's magnificent death. The astronomer Carl Sagan famously said, "We are made of star stuff," and he was speaking a quiet, literal truth. We are the children of the supernovae. The great cosmic river has become a beautiful, enriching cloud, fading slowly back into the interstellar sea. But in the silent, empty space at the heart of this fading cloud, something was left behind. The crushed heart of the star itself remains. The beautiful, enriching cloud of the supernova fades over thousands of years, its precious cargo of new elements seeding the cosmic ocean. But back at the very heart of the explosion, in the silent, empty space where the star's core once was, something remains. It is the star's crushed heart, the anvil upon which the new elements were forged. It is one of the most extreme, most bizarre, and most beautiful objects in the entire universe. It is a neutron star. Imagine a perfect cosmic spinning top, no larger than a city, floating in the center of a vast dark room. It is made of a substance so smooth and so dense that it seems to absorb the very darkness around it. Before the great collapse, this object was the star's slowly rotating core, but as it fell inward, its spin accelerated, just as a skater spins faster when she pulls in her arms. Now, in its compressed state, it is spinning with an impossible speed, rotating hundreds of times every single second. At its magnetic poles, this furious rotation generates two brilliant focused beams of energy, like the impossibly bright beams of a celestial lighthouse. As the object spins, these two beams sweep across the cosmos in a silent, rhythmic, and perfect pulse. This is a neutron star. When the star's core collapsed, the force was so great that it overcame the quantum law that keeps white dwarfs stable. The crush was so violent that it physically forced the protons and electrons together, merging them to form a new neutral particle, a neutron. The entire core has become a single solid sphere of pure neutrons, packed together as tightly as the universe will allow. It is, in essence, a single gigantic atomic nucleus the size of a city, yet it contains more mass than our entire sun. A single sugar cube of this neutron star material would weigh 1 billion tons. It is the densest form of matter in the known universe. For years, this was just a wild, beautiful theory. But in 1967, in the quiet fields outside Cambridge, England, a young graduate student named Jocelyn Bell Burnell noticed something strange. While scanning radio signals from the sky, she found a source that was pulsing with a regularity so perfect, so impossibly precise, that it defied all explanation. For a brief, exciting moment, she and her advisor wondered if they had found a signal from an alien civilization, jokingly labeling the source LGM-1 for Little Green Men. But they soon realized the quiet truth. They had discovered the lighthouse. They were seeing the steady, rhythmic beam of a spinning neutron star, the first pulsar, sweeping past the Earth with every single rotation. What this really means is that a neutron star is a monument to matter at its absolute limit. It is not burning. It is not shining with its own light. It is a cosmic memory, a piece of crystallized physics. Its rapid spin and brilliant beams a fading echo of the magnificent collapse that created it. The universe has taken the heart of a star that was once millions of miles wide and has compressed it into a perfect, tiny jewel of almost unimaginable substance. A furiously energetic ghost, still dancing in the graveyard of its own creation. This is the final, unbreakable flaw for most massive stars, the point where the laws of the quantum world make their last and most powerful stand against the force of gravity. But the next clue sits in the background noise, in a silence even deeper than this. However, for the most massive stars of all, the river of their being is so powerful that even this flaw cannot hold it. For the most massive stars of all, the celestial giants that dwarf even the brilliant blue titans, the river of their being is too powerful. The unyielding crystalline flaw of the neutron star is not enough. For them, gravity's victory is not just a win, it is a total and absolute conquest of reality itself. When the core of such a star collapses, there is nothing, not even the fundamental laws of matter, that can stop it. The fall does not end. The crush continues, past the density of a neutron star, past any known law of physics, until all the mass of the star's heart is squeezed into a single, infinitely small, infinitely dense point, a singularity. It is a wound in the very fabric of space-time. To understand what this creates, we must leave the world of objects and begin to think about the shape of space itself. Imagine that space-time is a great, wide, and perfectly flat river, flowing so slowly it seems to be still. Any object with mass, like a planet or a star, creates a gentle, shallow dip in the riverbed. The water of space-time flows into this dip, creating a slow, gentle whirlpool. This is gravity. Now imagine what the singularity does. It does not create a dip. It punches a hole clean through the riverbed. It creates a silent, cosmic waterfall. Far from this waterfall, the river is calm. You could float here for eons and never notice a current. This is deep space, far from the influence of the black hole. As you drift closer, a slow, inexorable current begins to pull you forward. If you had a powerful enough engine, you could still turn and escape its pull. But then, you cross an invisible line in the water. It is not a wall, it is not a wall, it is not a gate. There is no signpost. The water here is just as dark and just as calm as it was a moment before. But once you cross this line, the current of space-time itself is flowing toward the waterfall faster than anything in the universe can travel. It is flowing faster than the speed of light. This invisible, peaceful boundary is the point of no return. It is the event horizon, and the waterfall itself is the black hole. When Albert Einstein first saw these predictions emerge from his own beautiful equations of general relativity, he refused to believe them. He, like many others, found the idea of a singularity, a place where his own theory broke down, to be a mathematical ghost, a flaw in the logic that nature would never allow. And yet, the mathematics was relentless. It showed that if you had enough mass in a small enough space, the waterfall was an inevitable consequence. For decades, it remained a beautiful and terrifying ghost in the machine of physics, until astronomers began to see the evidence. Stars orbiting what looked like pure, empty nothingness, their paths tracing the perfect, silent whirlpool of a hidden, massive object. What this really means is that a black hole is not a thing that pulls. It is a place where space itself is falling. It is not a cosmic monster that hunts and devours. It is a feature of the cosmic landscape, a natural and unavoidable consequence of gravity. It is the ultimate expression of the universe's quiet tendency to gather things together, taken to its most extreme and beautiful conclusion. It is a place of profound and perfect silence, where the story of a great star has come to a final and complete end, its light and substance removed from our universe forever. This feels like the universe's final word, a place of ultimate stillness and departure. Yet the same process that created this silence also sowed the seeds for a new and vibrant beginning. The story of the star seems to end in the perfect silent waterfall of a black hole, a place of ultimate departure from our universe. And for that single magnificent star, the story is indeed over. But the great creative act of the supernova, the violent and beautiful explosion that can also lead to this silence, is not an end, it is a beginning. The same process that creates the universe's most profound endings is also the one that sows the seeds for its most beautiful new beginnings. This is the great cosmic cycle. Imagine a vast, ancient, and primordial forest, the very first one to grow on a new world. The trees here are simple, hardy things, growing from a thin, rocky, and nutrient-poor soil. They are the first generation, drawing their life from the simplest ingredients available. For 1,000,000 years, this forest lives and grows, a quiet and simple ecosystem. Then, one of the greatest and most ancient of these trees, a true giant of the forest, comes to the end of its life. It falls in a great and thunderous event, returning all of its substance to the forest floor. Over the next 1,000 years, it slowly, peacefully decomposes. All of the complex and beautiful materials it created during its life, the rich lignins in its wood, the minerals it drew from deep in the earth, are now released back into the soil. The forest floor, which was once just crushed rock and thin dust, is now a deep, dark and fertile loam, rich with the memory of the life that came before it. And now, in this newly enriched soil, new seeds can begin to grow. But these are not the same simple trees as before. This new generation of saplings, nourished by the legacy of the first, can grow into something more complex, more vibrant, and more diverse. The death of the one has enabled the flourishing of the many. This is the story of our universe. The very first stars were the ancient primordial trees, born from a simple soil of only hydrogen and helium. Their lives were magnificent, and their supernova deaths were the great falling giants that enriched the cosmic soil. The beautiful expanding clouds of their remains, seeded with carbon, oxygen, iron, and gold, are the fertile loam that mixes back into the interstellar medium. So when gravity, the patient gatherer, begins its work once more, coaxing a new cloud to collapse, it is not working with the same simple ingredients. It is working with a rich, complex, and metal-heavy mixture. What this really means is that the universe has a memory. It learns from its own history. Each generation of stars enriches the raw material for the next, allowing for ever greater complexity. Our own sun is not a first-generation star. It is a child of this great cycle, born from a cloud that was seeded by the ashes of countless stars that lived and died long before it. The rocky planet we are on, the very ground beneath our feet, could not have formed in that first simple generation. There was no silicon, no iron, no nickel. Our world is made of recycled stars. This beautiful, patient cycle of stellar death and rebirth isn't just a distant cosmic story. It is the quiet, direct path that leads to our own beginning. The great cosmic cycle, this beautiful rhythm of death and rebirth, creates a universe that grows richer and more complex with every passing generation. But this cycle too is finite. The vast clouds of gas and dust from which new stars are born are not an infinite resource. With every new star that is created, and with every old star that locks its mass away into a white dwarf or a black hole, the universe's nursery is slowly, inevitably being depleted. And so we look now to the far speculative future, a time so distant it makes the current age of the universe seem like a fleeting instant. We look to the universe's long and final twilight. Imagine yourself in that great dark hall of the cosmos, where every star was once a brilliant burning candle. The era we live in now is the time of the great burning. The hall is filled with 1 billion points of brilliant light. But as we journey forward in time, into the trillions of years, we see the great flames begin to flicker and die. Star formation has ceased. The universe has used up all its free gas. The nurseries are empty. The last of the massive stars have exploded. The last of the sun-like stars have puffed away their gentle ghosts. And the long-lived red dwarfs, the patient embers of the cosmos, are finally beginning to burn out. One by one, the candles are extinguished. Soon, the only light left in the great hall comes not from the flames, but from the faint, beautiful, residual glow of the smouldering wicks. This is the era of the white dwarfs, the cooling embers, the stellar remnants that will spend the next quadrillion years, slowly, patiently, giving away their last reserves of heat. For an almost unimaginable eternity, the universe will be a place of profound and deepening darkness, punctuated only by these tiny, fading points of ghostly white light. And then, one by one, even these last embers will cool. They will radiate away their last whisper of warmth, finally reaching the same temperature as the cold, empty space around them. They will cease to glow. The last light in the universe will go out. This is the theoretical end state of a star like our Sun. This is the black dwarf, a cold, dark, invisible sphere of crystallized carbon and oxygen, a planet-sized diamond floating in a perfect and eternal darkness. It is no longer a star, not even an ember. It is a memory of a star, a final, silent monument to a light that has long since faded. The universe will become a vast, silent, and impossibly cold graveyard, filled with these dark ghosts, as well as the neutron stars and black holes, all drifting through an endless starless night. This is the universe's final, peaceful state of equilibrium, the great heat death, a gentle and poetic term for a universe that has finally run out of energy and settled into a deep and final sleep. What this really means is that the universe itself has a lifespan, a story that will come to a quiet and graceful end. It will not end in a great fire or a great collapse, but in a slow, patient, and inexorable fade to black. It is a future of profound and ultimate stillness, a return to the perfect quiet that existed before the first star ever lit up the dark. It is a humbling and peaceful thought to see our own vibrant, light-filled era as a brief, beautiful, and fleeting moment of cosmic springtime before the long, slow autumn and the final, quiet winter arrives. But the light and the dust from that long-ago fire carry one more message, a much warmer and more personal one. This long, speculative journey to the cold, dark end of the universe can feel distant and humbling, a story of such immense scale that it seems to have little to do with us. But the truth is, the story of the stars is the most intimate and personal story there is. The grand cosmic cycle of birth, life, and death is not something that happens out there in the distant, untouchable heavens. It is a story that is written in the very substance of your own being. We are made of stardust. Imagine you are holding in your hands a small, beautiful, and intricate glass orb. Inside this orb is a perfect miniature model of our solar system, with the sun, the planets, and even the tiny blue dot of Earth. Now imagine you could trace the origin of every single grain of sand, every single speck of pigment used to create this beautiful model. You would find that the clear glass of the orb itself came from one ancient source, a simple and foundational material. This is the hydrogen and helium, forged in the Big Bang, the primordial glass from which the universe is made. But then, you look at the tiny, vibrant blue sphere of the Earth. Where did the blue come from? Where did the flecks of green and brown come from? If you could trace their history, you would find that each of these colourful grains came from a different, far more dramatic place. The tiny speck of iron that makes the rich, red soil of a continent was forged in the heart of a star that lived and died in a brilliant supernova. The wisp of oxygen that gives the blue its depth was created in the core of a red giant and gently puffed away in a planetary nebula. The glint of gold in a riverbed is a fragment from the heart of a cosmic explosion that outshone a galaxy. The very carbon that forms the basis of the miniature trees and plants was born in the final, desperate fire of a dying sun-like star. Every complex and beautiful detail of this tiny world is a gift from a star that lived and died long before this world ever came to be. Now, put down the glass orb and look at your own hands. The story is the same. The hydrogen atoms in the water that makes up your body are the ancient, primordial glass, 13.8 billion years old. But the carbon in your tissues, the nitrogen in your DNA, the calcium in your bones, the iron in your blood, every single one of these heavier atoms was created inside a star. We are not just living on a world made of stardust. We are the stardust. The universe, through the long, patient, and sometimes violent lives of its stars, has slowly learned how to create the ingredients for life, and we are the living, breathing, and conscious result of that great cosmic experiment. What this really means is that we are not separate from the universe, looking in from the outside. We are a part of it. We are the cosmos made aware of itself. The same atoms that once burned in the heart of a distant, long-dead sun now form the intricate and beautiful network of your own brain, which is capable of pondering the very stars from which it came. This is the most profound and beautiful connection of all. The universe is not a story that is happening around us. It is a story that is happening through us. When we look up at the night sky, we are not just looking at distant objects. We are looking at our own ancient cosmic ancestry. This connection does more than just explain where we come from. It gives us a new and deeply soothing sense of time itself. This beautiful, profound connection to the stars, the knowledge that we are their children, does more than just tell us where we come from. It gives us a new and deeply soothing sense of time itself. In our daily lives, time often feels like a pressure, a race, a thing that is always running out. We are governed by the clock, by schedules, by the feeling that we must hurry. The world moves at a frenetic pace, but when we allow our minds to float in the gentle, vast river of cosmic time, that pressure simply dissolves. Imagine you are standing at the bottom of a great and ancient canyon, carved over millions of years by a slow, patient, and persistent river. The air here is cool and still, and the only sound is the soft, steady murmur of the water as it glides over smooth, ancient stones. You look up, and the canyon walls rise for a mile above you, a sheer cliff of deep red and orange rock. You can see the layers in the stone, a perfect physical record of time itself. Each layer is a chapter in the Earth's own long story, laid down slowly, one grain of sand at a time. The sun, a tiny brilliant disk in the sliver of blue sky far above, traces a slow and majestic arc, its light taking hours to creep down one wall and up the other. To be here is to be surrounded by a stillness that is not empty, but full of a deep, quiet and powerful sense of age. Now, think of your own life, your own worries and deadlines in this place. They are like a single tiny swirling eddy in the great calm river. They are a brief and beautiful pattern of ripples that appears for a moment and then is smoothed away by the river's immense, unhurried and forward flow. To feel this is not to feel small or insignificant. It is to feel a sense of profound and lasting peace. It is to be released from the tyranny of the immediate. The river does not hurry, and the stone does not rush, and yet the canyon was carved. The universe accomplishes its greatest and most beautiful work not through speed, but through an immense and unwavering patience. What this really means is that our lives are a brief, precious and beautiful moment, set against a backdrop of almost infinite patience. The 10 billion year lifespan of our sun is the ancient stone of the canyon wall. Our own brief, fleeting existence is like a single hardy wildflower, blooming for one bright season in a crack in that ancient stone. The flower's brief life is not made meaningless by the age of the rock. It is made more beautiful, more poignant, and more precious. This perspective, first grasped by geologists and astronomers who gave us the gift of deep time, is a form of meditation. It is the quiet understanding that our frantic sense of urgency is an illusion, and that we are part of a story so old and so slow that it is, for all intents and purposes, eternal. This immense river of time doesn't just flow past us, and the light that travels on its currents carries one more quiet message about the deep past. That immense river of time doesn't just flow past us, it flows to us, carried on the gentle and patient currents of starlight. When we step outside on a clear, dark night, and look up at the vast, glittering canopy of the sky, we are not just seeing a collection of distant lights, we are seeing a collection of distant moments. The sky is not a static ceiling painted with stars, it is a deep, layered and profound museum of ancient light. Imagine you are standing in a vast, dark and perfectly silent museum hall. The hall is so large it has no visible walls or ceiling. Floating in the darkness all around you are 1,000 beautiful, illuminated photographs. You walk up to the nearest one. It is a portrait of a person who lived a year ago, their image carried to you by the light that bounced off them and was captured by a camera. You move to the next one, a little further away. This is a photograph from a decade ago. Further still, you see a faded, sepia-toned image from a century in the past. As you walk deeper into the hall, you are walking deeper into time. The photographs are of ancient ruins, of long-extinct animals, of the world as it was thousands, and then millions of years ago. The museum is not organized by subject, but by time itself. This is the nature of the night sky. Light, though it is the fastest thing in the entire universe, does not travel instantaneously. It takes time for its journey. The light from our nearest stellar neighbor, Proxima Centauri, has traveled for 4 years to reach our eyes. When we look at that tiny point of light, we are not seeing the star as it is tonight. We are seeing it as it was 4 years ago. We are looking at a photograph of its past. The brilliant star Vega is 25 light-years away. We see it as it was a quarter of a century ago. The light from the beautiful star cluster Pleiades began its journey to us 400 years ago, around the time Galileo was first looking at the sky with his telescope. And as we look deeper, the time spans become breathtaking. The Andromeda Galaxy, a faint fuzzy patch of light visible to the naked eye, is not a star, but a city of 1 trillion stars. And the light we see from it tonight has been traveling for 2.5 million years. When that light began its journey, our own species did not yet walk the Earth, and the light from the most distant objects we can see with our greatest telescopes has been traveling for over 13 billion years. A message from the dawn of the cosmos, a photograph of the universe in its infancy. What this really means is that looking at the night sky is an act of time travel. It is the only place we can look where the past is directly and beautifully visible. The universe is showing us its own history, laid out in a panorama of breathtaking depth. The light we see is a collection of ancient messengers, each one carrying a memory of the star where it was born, a memory that has been preserved in its perfect, uninterrupted flight across the vast, quiet emptiness. There is a deep and soothing comfort in this. The past is not lost. It is still there, shining down on us from every direction, a constant and gentle reminder of the universe's immense and beautiful story. And at the very center of our own small room in this great museum, there is our personal connection to this story, our own private star. In the midst of this vast cosmic museum, where every point of light is a window into the deep past, it is easy to feel that the stars are distant, abstract, and have little to do with our immediate world. But we do not need to look into the deep night to feel our connection to the cosmos. We have our own star, a personal, intimate, and life-giving presence that is not a distant point of light, but a warm and brilliant disk that dominates our sky. This is our sun. Imagine you have spent a long, dark, and cold night in a vast, unfamiliar wilderness. The world is a place of deep shadows and uncertain shapes. A profound and ancient cold has settled into your bones. You have huddled for warmth, waiting for the dawn, and then it comes. At first it is just a faint pearlescent glow on the eastern horizon, a quiet promise. Then a single brilliant sliver of light crests the distant mountains, and in an instant the world is transformed. The light, the color of pure molten gold, spills across the landscape, chasing the shadows away. The air, which was sharp and cold, is now touched with a gentle spreading warmth. You turn your face to the light, and you can feel it on your skin, a direct and physical connection to that rising star. It is a feeling of profound relief, of homecoming, of a deep and primal reassurance. This is our daily connection to the sun. We have become so accustomed to its presence that we can sometimes forget the quiet miracle of its constancy. It is the star that warms the air we breathe, the light that powers the growth of every plant we eat, the energy that drives the weather and the oceans. For 4.5 billion years, it has been the quiet, unwavering, and life-giving heart of our world. It is not just a scientific object, a ball of hot gas governed by the laws of physics. It is the central character in the story of our planet, the gentle parent that has nurtured the slow, patient unfolding of life in all its forms. The quiet, patient work of astronomers like Nicolaus Copernicus, who first dared to place the sun at the center of our solar system, was more than just a scientific revolution. It was a profound shift in our human perspective. It taught us that our world was not the center of all things, but that we were in a beautiful, graceful, and eternal dance with our star. We are a planet defined by our relationship to our sun. Our days, our years, our seasons, the very rhythm of our lives are all governed by our steady, predictable journey around its gentle fire. What this really means is that we have a direct and personal connection to the grand stellar story. We don't need a powerful telescope to see the process of nuclear fusion at work. We can simply step outside and feel its warmth. The sun is our local embassy of the cosmos, a constant and beautiful reminder that the same immense and powerful forces that build and shape the galaxies are also at work right here in our own celestial backyard, providing the calm and stable conditions that make our own quiet existence possible. The light and the laws that govern our sun are not unique to it. They are the same laws that bind and guide every star and every one of us, creating a deep and universal sense of belonging. The gentle, life-giving warmth of our sun feels like a special and personal gift, a fire lit just for us, and in a way it is. But the laws that govern its light, the quiet principles that hold it in its perfect shimmering balance, are not special at all. They are the most common and universal laws that exist. The same gentle whisper of gravity that holds our world in orbit is the same whisper that gathers the cosmic dust to form new stars a million light-years away. The same elegant dance of fusion that powers our sun's core is the same dance that illuminates the most distant galaxy. The same laws of light and energy that warm our skin are the same laws that carry a message from the beginning of time to the lens of our greatest telescopes. Imagine you are standing on a vast, dark and silent shoreline at night, looking out over an ocean of impossible size. The water is perfectly still, and the sky above is a brilliant, unfamiliar tapestry of stars. You feel a profound sense of solitude, of being in a place that is entirely alien to you. Then, a gentle rhythmic sound begins. It is the sound of the tide, the soft, steady and patient whisper of the waves breathing against the shore. And in that sound you recognize something. It is the same rhythm, the same gentle and universal cadence as the ocean on your own home world. In that moment, the strange and alien shore no longer feels so lonely. You are connected, through this simple universal law of tides, to the place you came from. You are part of the same single cosmic ocean. This is the quiet beauty of the physical laws of our universe. They are the grammar of the cosmos, the simple, elegant, and unwavering rules that are spoken and understood in every corner of existence. The forces that hold the atoms of your own body together are the very same forces that forge new elements in the heart of a supernova. The electrical signals in your own brain that allow you to have a thought are governed by the same principles that create the brilliant beams of a pulsar. There is no separate physics for out there and in here. It is all one unified, coherent and beautiful system. For centuries, humanity looked up at the heavens and imagined them to be a place of perfection, of divine and unknowable laws, utterly separate from our own messy and chaotic world. The great quiet revolution of science, from Newton to Einstein, was the slow, dawning realization that this was not true. It was the understanding that we are not separate from the cosmos, but are a seamless and integral part of it. The universe is not a house with a different set of rules in every room. It is a single, beautiful, and consistent home. What this really means is that we belong here. We are not accidental tourists in a strange and hostile universe. We are native to it. We are built from its laws and animated by its energies. There is a deep, abiding and soothing comfort in this. It is the feeling that, no matter how vast and mysterious the cosmos may seem, we are fundamentally and irrevocably at home within it. And this feeling of a shared home leads us to one final, quiet, human realization. This profound sense of being at home in the universe, of being governed by the same gentle and universal laws that shape the stars, leads us to one final, quiet, and deeply human realization. We are not just sharing a set of physical laws with the cosmos, we are sharing a physical journey. Every single human being who has ever lived, and every living creature we have ever known, is a fellow passenger on a single beautiful and fragile world, on a shared voyage around our star. Imagine you are on a great and ancient ship, sailing across a vast, dark and empty ocean. The ship is so large that you can live your entire life on its decks. You can explore its forests and its mountains, without ever being consciously aware that you are on a journey at all. You can be born, live and grow old in a single small village on this ship world, and believe that your village is the entire universe. You can see the people in the next village, across the river, as strangers, as others, living in a different world governed by different rules. But then, one clear, quiet night, you climb to the highest mast of the great ship, and from this vantage point, for the first time, you can see it. You can see the gentle curved edge of your world against the glittering backdrop of the distant starry ocean. You can feel the slow, steady and almost imperceptible motion of the ship as it glides through the cosmic water, and in that moment, the illusion of your separateness vanishes. You realize that your village, and the village across the river, and every other place on this world, are all part of the same single beautiful vessel. You are all sailors on the same voyage, your fates bound together on a shared journey through the vast and silent dark. This is the gift of the cosmic perspective. It is the view first seen by the astronauts who looked back at our Earth from the quiet desolation of the moon, who saw our entire world not as a complex map of borders and divisions, but as a single, beautiful, and irreplaceable pale blue dot, a fragile oasis of life in the immense silent void. This perspective gently and quietly dissolves our sense of separation. We are all citizens of a planetary vessel, kept alive by the same thin, precious atmosphere, warmed by the same gentle, distant star. What this really means is that the story of the stars is not just a story about physics and chemistry, it is a story about connection. It reminds us that our shared cosmic address is far more fundamental than any of the temporary and imagined boundaries we create on the surface. We are a single family, orbiting our personal star together, bound by a common origin in the heart of a supernova and a shared destiny tied to the long, slow life of our sun. There is a deep and quiet sense of unity in this idea, a peaceful recognition that we are, all of us, in this together. And to be together on this beautiful sun-warmed ship, in this particular quiet moment of its long voyage, is a reason for a deep and profound gratitude. And so, to be here together, on this beautiful sun-warmed ship, in this particular quiet moment of its long voyage, is a reason for a deep, abiding and profound sense of gratitude. The universe, as we have seen, is a place of immense and unimaginable power. It is a place of supernova explosions that can sterilize a solar system, of crushing black holes that can swallow light itself, and of a vast, cold emptiness that stretches for eons between its islands of warmth. And yet, here we are, here we sit, in a moment of almost impossible peace. Let us return, one last time, to the deck of that great and ancient ship, our Earth, as it sails through the cosmic sea. Tonight, the sea is calm. The waters are a vast, dark and perfect glass, reflecting the distant, silent glittering of the stars. The ship moves with a slow, steady, and almost imperceptible rhythm, a gentle and reassuring glide through the quiet dark. There are no storms on the horizon. The engine room, our sun's core, is humming with a steady, reliable and peaceful tune that has not changed in billions of years. The air is breathable, the warmth is gentle, and the ship is, for now, a perfect and complete sanctuary. This is our moment. This is the great good fortune of our existence. We are living in the long, quiet, and peaceful summer of our star's life. We are traveling through a safe and gentle patch of the cosmic ocean. We were not born in the universe's chaotic and fiery youth, a time of constant collisions and cosmic violence. We are not, it seems, destined to see its final cold and lonely twilight. We are here now, in the perfect high afternoon of it all, a golden age of cosmic tranquility that has allowed for the slow, delicate and beautiful miracle of life to unfold, undisturbed. What this really means is that our existence is a gift of stability. The very fact that you can lie here, in a warm and comfortable place, and peacefully ponder the nature of the universe, is a testament to the immense and patient calm of our particular corner of the cosmos. The Earth's orbit is stable, the sun's light is constant. Our solar system is not being torn apart by a passing star or bathed in the lethal radiation of a nearby supernova. This quiet, predictable and uninterrupted peace, stretching over billions of years, is the fertile ground in which our own consciousness was allowed to grow. It is the long, silent pause in the cosmic symphony that has allowed for our own brief and beautiful melody to be heard. There is a deep and soothing peace to be found in this gratitude. It is the quiet recognition that, in a universe of staggering power and occasional violence, we are, for now, safe. We are the beneficiaries of a long and unbroken chain of cosmic good fortune. To feel this is to feel a sense of profound and gentle appreciation for the simple, quiet, and beautiful reality of this present moment. And so, this feeling of quiet gratitude brings our great journey full circle, right back to the simple ancient question we first asked under the velvet darkness. And so, our long and quiet journey comes full circle, returning us to the velvet darkness where we first began, with a simple, ancient, and almost childlike question. How are stars born? How do they live? And how do they die? We thought we were asking about distant, fiery objects, scattered like diamonds on a black cloth, but the journey has taught us that the question was never really about them. The question was always about us. We began in the quiet, cold ocean of space, in a fine, invisible mist of the universe's oldest and simplest atoms, and we learned that this emptiness was not an absence, but a promise, a cradle. We watched as the patient, gentle whisper of gravity gathered that mist into a dark and silent nursery, where the first faint stirrings of warmth began. We felt the immense building pressure in the heart of a protostar, a cosmic crucible that finally, beautifully, overcame the forces of nature to ignite the steady, quiet hum of nuclear fusion. We saw how a star found its long and peaceful life in a perfect, elegant balance, a serene and steady afternoon that could last for 10 billion years. And from that life we saw the birth of gentle, life-giving warmth, the creation of gardens in the cosmos where the seeds of new stories could be planted. We learnt that the death of a star was not an end, but a transformation. We saw the sun-like stars swell into magnificent red ghosts, gently letting go of their substance to create beautiful, ethereal butterflies of light in the darkness, leaving behind a tiny, cooling diamond heart. And we saw the giants of the cosmos end their short, brilliant lives in a final, glorious blaze, a supernova that forged in its heart the very elements of our world, the iron in our blood and the gold in our hands. And we learned that this great cosmic cycle of death and rebirth is not a distant, abstract story. It is our own origin story. We are the children of the stars. Every atom in our being is a tiny, glittering fragment of a star that lived and died long before we were ever born. In the end, the journey did not provide us with a simple list of answers. It did not give us a chart or a diagram. Instead, it gave us a sense of connection, a feeling of belonging to a story of unimaginable scale and beauty. It taught us to see the night sky not as a collection of objects, but as a family album, as a quiet and constant reminder of our own deep cosmic ancestry. And so, as you settle in now, as you let the last of these words wash over you, perhaps you can feel that connection. Feel the quiet, steady hum of the universe within you, the ancient stardust that is dreaming, for a brief and beautiful moment of itself. The story of the stars is our story, and now it is time to rest. Good night.